Draw a circle with radius 1. Next, inscribe a rectangle along with an isosceles triangle so that they share one side. Call the length of the rectangle x. The question is, for what x is the area of the rectangle equal to the area of the triangle? Doing some labeling might help. Let's call the side of the rectangle shared with the triangle B for base. We know the area of the rectangle is length times width, in this case x times b. The area of the triangle is 1/2 base times height, in this case 1/2 b times h, if we label the height of this triangle h. To solve our problem, these two areas are supposed to be equal. One nice thing is that we can cancel b on both sides. We're assuming b isn't 0 here, otherwise we wouldn't have any shapes at all, so we're allowed to divide by b. And so we've solved for x. But the issue is we have this extra unknown h. The only piece of info we haven't really used yet is that the radius of the circle is 1. What's interesting is if we draw the radius through the triangle like this, we see what that distance 1 is really made up of. It's the entirety of h, since it goes through the triangle, plus half the distance of x. The rectangle is length x, so half the rectangle length would be x over 2. This works because the center of the rectangle and the center of the circle happen to be the same. So 1 must be h plus x over 2, giving us a second equation to let us solve for our second unknown variable. H has to be 1 minus x over 2, then we can substitute for h in our area equation. X equals 1 minus x over 2 all over 2. Multiplying both sides by 2, we would get 2x is 1 minus x over 2. We can add x over 2 to both sides to give us 5/2 x is 1, or dividing by 5/2, x is 2/5. The value of x which makes the area of the rectangle and the triangle equal.